Thanks for joining me in today's lesson. In this first tutorial, we will find one-sided limits. And we are in section 13.3, one-sided limits. So what one-sided limits are, we're talking about limits from each side. So we actually have two new symbols. If we're talking about some function f of x, we could say that the limit as x approaches c with a little negative up here in the superscript of f of x, this is the left-sided limit because of that negative. Or we could have the limit as x approaches c with a little plus sign up in this superscript area, and that of course would be the right-sided limit because it's a plus sign. So we just need to know which side we're talking about to find the one-sided limits. Example number one, we've kind of seen a graph that looks like this before. I'd like to know what the limit as x approaches 0 of the absolute value of 2x divided by x. Perhaps graphically this might make some more sense to see with the graph. So I'm going to go ahead and sketch a quick graph of this. I'll put 1, 2, and 1, 2 down here. 1, 2, 3, 4, and 1, 2, 3, 4. Let's just do a quick sketch of this. So I can plug in whatever I want for x. Of course, unfortunately, the 0 that I can't plug in. If I plug in a 1, let's do some positives. 2 times 1 divided by 1 would be 2. And if I plug in a 2, 2 times 2 would be 4, divided by 2 would also be 2. If I plug in a 3, I get 6 divided by 3, which is 2. And for the same reasons that with the other time we've seen this graph, every one of these positive inputs would yield a positive output of 2. And 0, I'll put an open circle. Let's see what happens when I plug in some negatives. If I plug in a negative 1, the numerator will continue to be a positive, but the denominator will change it to a negative output. And it'll be down here. And this is what our graph will look like for negative inputs. So that's what our graph looks like. And I'm talking about one-sided limits. It says find the limit from each side. So I've got two different symbols that I'm looking for. The limit as x approaches 0 from the left side of this absolute value of 2x over x. Let's talk about that. So this means the left side of 0. So let's get to 0, and then let's get on the left side of 0 and start getting closer and closer and closer and closer to 0 from the left side. Well, if we follow the graph, follow the function, you can see that we're trying to get to the value of negative 2. And that's why this one-sided limit equals negative 2. It's right there. The right-sided limit, let's say we're talking about the limit as x approaches 0 now from the right side, so we need a little plus sign of this function, absolute value of 2x over x. Let's see that. Well, so we have to get to the right side of 0 and get closer and closer and closer and closer from the right side, and you can see that the function is trying to become this value, which is positive 2. And that's why this one-sided limit equals 2. So last question, what if I actually wanted the limit as x approaches 0 of this function? We can call it the overall limit. If this is the left-sided limit and this is the right-sided limit, then maybe we call this the overall limit. And what would that be equal to? What is the limit as x approaches 0 of this function? Well, I hope you're all saying does not exist, because this is one of the cases where the full ultimate limit does not exist. We cannot be approaching two different values. And that's part of today's lesson. We're talking about continuity and when functions are continuous. And one thing that has to happen is the one-sided limits have to be the same for the limit to even exist. This was case number 1 where a limit did not exist. But the left-sided limit exists and the right-sided limit exists, but because they're two different numbers, 2 and negative 2, then the overall limit does not exist. So let's flip over and look at example 2. The directions say find the limit as x approaches 3 with the plus sign. That means the right side of h of x. H of x happens to be a piecewise function. It equals 3 different pieces depending on the domain. So I wonder what we're supposed to do if we're looking for the right-sided limit, the right side of 3. Which piece are we even talking about? Obviously, we're going to try to do direct substitution, and we're going to try to plug in a 3. Do we plug in a 3 into here, or do we plug in a 3 into here, or do we plug a 3 into here? Well, which of these domains describes the right side of 3? I don't care what happens when x equals to 3. I care about what's happening on the right side of 3, and this is the right side, obviously greater than 3. So what I'm going to do is I'm going to plug my 3 right in there. So this limit as x approaches 3 from the right of h of x is equal to 3 minus 2, which is equal to 1. So you just need to be mindful of which part of the domain we're talking about. If we're talking about the right side, then we're talking about the right side. So let's make that part A. And let's do a part B for this problem. Let's say part B, I want to find the limit as x approaches 3, but from the left side of h of x. Hopefully it's a little bit more obvious what we're going to do now. If we're talking about the left side of 3, then we must be talking about numbers that are less than 3. This would be the left side. So we'd be using this part of the function. So I can plug a 3 into that, and I'd have 2 times 3 minus 1, which would be equal to 5. So the right-sided limit in part A we got was equal to 1, and the left-sided limit in part B existed as well, and it equals to 5. So let's do this. I know what I'm going to do. I'm going to put a part C now. And let's say the limit as x approaches 3 of h of x. Not a right-sided limit, not a left-sided limit, but the overall limit as x approaches 3. I wonder what that would be for this function. Well, hopefully you're all telling me does not exist. And you're right, for the same reason as example number 1. The one-sided limits are not the same values, so therefore this limit does not exist overall. Now please don't say, well, I could just plug a 3 into the function here and say that the limit is going to be 7. It's not about what happens exactly at 3. It matters what happens to the left of 3 and to the right of 3. That's what a limit is all about. It's not a picture of 1 second in time. It's a continuum of what this function is trying to become on each side of your domain point. Thanks for watching that about one-sided limits, and I'll see you in the next tutorials.